Like LEDs, more LEDs.
LEDs everywhere. I like it.
Well, Josh, if engineering could be formed into a massive cybergenetic creature, you would be the cold liquid metal pumping heart.
Yes. Welcome to Engineer versus Designer.
The podcast.
For product designers, engineers, and anyone who gets excited about tools that make tools that make tools that make tools that make other tools.
All right, stop it, Josh.
My name is Josh, mechanical engineer of SolidSmack.com.
And my name is Adam, industrial designer of CADJunkie.com. Each week's show is broken into 3 plastic pump and halves. This week we're going to roll up our sleeves and see what we can glean on the DIY scene. First, we'll lay down some nifty facts and figures on fab, courtesy of SolidSmack.com.
Followed by design process tips, tricks, and insight compliments of CADJunkie.com.
And today we have plastic smacker, material hacker, tinkerer, stinkerer, co-founder and CEO of MakerBot Industries, the Mr. Bre Pettis.
Yes, Bre, welcome, good sir. If you... Great. If a MakerBot could print living things, what living thing would you print?
I think we just have to, I'd like to have just, either a brain in a jar on my desk, just with ideally like an LED display or so that's kind of what I'd go for.
All right. Brain with LEDs. Thanks, Bre. Sit tight. We'll be hearing more from you as the show goes on. Speaking of morally questionable homebrew experiments, Josh Mings of SolidSmack.com. Puree our ignorance with the mind-grinding blender of knowledge. What have you got for us this week?
This week's SolidSmack update is brought to you by the Printastic family of Stratasys 3D printers. Dimension 3D printers are the ABS printing machines of your dreams, taking models direct from your CAD software. Check them out at stratasys.com. Today, we bring you the history of MakerBot and some other stuff. It begins now.
So in 2005, the RepRap project, you remember that thing? Funded by the University of Bath in the UK.
Support structures on a 3D printed part are often removed with chemical baths, or in the case of MakerBot printers, a water and soap bath.
I occasionally do bathe with 3D printer parts. In November 2008, the first 3D printed replication occurs outside the RepRap project. The world will never be the same.
January 2009, MakerBot Industries enters the scene, co-founded in Brooklyn, New York, by Adam Mayer, founding RipRap member Zach Smith, and our special guest, Bre Pettis.
Woo-hoo! We did some Googling, Bre. Apparently, you were born in 1972 and have been a school teacher, artist, and puppeteer. We were particularly intrigued by the Three Piggy Opera being one of the many performed in 2005.
Yes. 5 years later, slices of a 3D printed pig's head were given to Master of Design graduates at the Design Academy in Eindhoven, Netherlands.
Coincidence? I think not. The same year, September 2010, MakerBot introduced the Thing-O-Matic, their second printer, with upgraded electronics, larger build area, and an automated build platform.
Small build platform on a 3D printer was created by Klaus Stahlmann, measuring 20 by 30 millimeters, creating sculptures smaller than a human hair with lasers and resin bath.
In January 2012, MakerBot introduced for the first time the MakerBot Replicator with 2-color printing and a massive build area. Super excited about that.
And people have been known to mod the MakerBot printers using laser pointers to turn them into laser cutters. Bre, what wild and crazy mods have you seen the MakerBot transformed into?
What's cool about being producing an open source 3D printer is we share all the design files, and people can open those up and modify them and do both wonderful and oftentimes stupid things. So probably one of my favorite things is somebody took a dragon head model and then, of course, hollowed out the eyes, put LEDs in it so it was like glowing evilly, and then mounted it to the front of their MakerBot. That's probably the most just decoratively wonderful thing. And then our first machine, the Cupcake CNC, which we basically was just literally engineered out of raw caffeine. We basically started working on it in January and shipped it in April, and like literally we could measure the prototypes by how many ramen packets we ate. When we launched that, it worked, and it was kind of exciting because it like worked. But there were a bunch of things that we just didn't have time to optimize. And when people got their cupcake, they started optimizing it. So they remade the Z stage, which is the part that goes up and down, so it would wobble less. And they remade the X and Y stage so that they could actually make taller things. So, it's one of those things where we launch something and we think it's the best thing possible, and our users are the most obsessive, creative engineers and designers in the entire universe. And so they're like, I can get another 0.5 millimeter out of this if I just spend a couple hours, creating a part on the MakerBot that can extend it a little bit. So wow. It's pretty awesome.
That's fantastic. And I remember hearing, and maybe this, I think this was you, right? Didn't you send out an upgrade to one of your pieces of hardware as a printable 3D file at some point?
Yeah, when we first started, there was a pulley on top of the machine, 2 pulleys actually, and we laser cut them. And it was one of those things where it worked, but it was really, really fussy. And after, a couple hundred hours, the part would wear out. So we sent out an email to everybody who'd ordered one and said, before you get to that point, print out these 2 parts and their little pulleys and break the old ones and stick the bearings in the new pulleys and you're good to go. And it was one of those things. What's interesting is then, of course, we started making those when we did that for all the people who had made them, but then we had to start making these parts on MakerBots for other MakerBots. And we were just getting so many orders, we ended up basically hiring our customers to make parts for our other customers. So if you had a MakerBot and you printed out these pulleys, you could send them in to us, and we'd send you $1 for each one. And
that is fantastic.
Kind of crowdsourced manufacturing. Yeah.
I can't wait to talk more about that. It basically just blew my brain, and apparently also it looks like my kidneys are splitting and growing kidney children.
Kidney children? Like kidney beans? That's just delicious with mac and cheese, really.
It's a little bit gross. We'll be right back.
Adam O'Hearn of CADjunkie.com. Stop pouring those plastic shavings into the molten nipple extruders of your chest cavity for a few seconds. What is on your mind this week, buddy?
This week's CAD Junkie Q&A is brought to you by Stratasys 3D printers, taking your 3D data from virtual to physical with ease. Designers, engineers, educators, and others are churning out amazingly detailed, durable prints with Stratasys Dimension printers. Make sure to go check those out at stratasys.com. Today we're talking with Bre Pettis, co-founder and CEO of MakerBot Industries. For those who don't know, maybe you live on the moon, MakerBot Industries makes home 3D printer kits so that anybody can have a 3D printer at home for $1,000 or less. Very, very exciting stuff. Now, first, before we get into kind of the bigger questions surrounding why you did this and the business, let's talk a little bit about the technical side of things a little bit. Bre, you guys have done some amazing stuff with 3D printers by making them look fun and accessible to the average computer user. But, I'm guessing that behind that simplicity on the outside, there's some serious technical challenges, underneath this thing. What were the most technically difficult parts of designing the original MakerBot, and then how has that changed over the last couple of years as you've evolved it?
One of the hardest things about designing the MakerBot was not the XYZ positioning system, but it turned out to be finding a material that you could extrude plastic onto where it would stick to the base, but then come off later, so it wouldn't stick permanently. Oh. So we actually, when we started, we just used foam core. Foam core is actually coated with a very fine ceramic coating, which, of course, plastic loves to stick to. The downside of this was that the foam core was disposable. Like once you used it, you had to throw it away, but it was really cheap. But it made everybody kind of unhappy because it was wasteful. So we came up with an acrylic solution where we laser cut acrylic and cut grooves in it so that the plastic, as you extrude it onto it, would kind of seep into the grooves and grip. And that was cool, but it eventually, it wasn't a long-term solution as well. It would work for a certain amount of time and then it would stop working. And then we discovered this magical thing called Kapton tape, polyamide tape. And this is a plastic film that actually, like if you've seen a satellite and it looks kind of like golden in color, that's because it's wrapped in Kapton tape. It has these amazing thermal properties, and it's just super cool, very radiation resistant as well. So it turns out we put this stuff down on the build platform, and plastic just loves to stick to it when it's hot, and then it doesn't stick to it when it's cool. So we put a heater underneath it.
Nice.
So when you're making something on a MakerBot, your object sticks to the base, and then when you're done, the base cools down, and it comes off really easily then, and can be reused over and over again.
That is fantastic, and you would never think that would be, of all things, the most difficult part. What do you think is the most technically challenging part of this for the average user, getting up and running with 3D printing, and then on the other side of that, how do we make that easier?
We just had a major shift at MakerBot up until January. When you got a MakerBot, you had to kind of delegate like 20 or 40 hours to actually assemble it. But at CES, we launched our latest machine, the MakerBot Replicator, which makes really big things, and it makes things in 2 colors with 2 nozzles, and then it comes assembled. So, like right now downstairs in our workshop, we're just cranking out replicators to get them ready to ship out in a couple weeks, and we're putting them together. And it was one of those things that when we designed it so when we designed our previous machines, we just wanted them to work, and we knew that people would put them together. But now we're making it so that it's really easy to put together, really easy to maintain and open up, and it actually takes us less time to assemble the machine than it did to assemble the kit for our last machine. So the replicator comes assembled, and it's super awesome.
Cool. Now the MakerBot is said to be open source. What does it mean for a piece of hardware to be open source, and why is that an important feature of the MakerBot?
So one of the cool things about being open source is we share our digital designs with people, and we share them under a license that basically says, you can go ahead and copy this. You can go ahead and make your own. But if you make any improvements or any changes, you have to publish those under the same license that we publish the machine. So basically, if you make any cool improvements, you have to share them back with the community. So kind of like, because we share, you have to share. Neener. The cool thing about that is it means that when you get a MakerBot, it is yours. Like, there's, you can take it apart, you can hack it, you can do whatever you want with it, you can modify it, and you get to know how it works. I mean, it's kind of like back in the, when I was growing up in the 80s, I would get a stereo, and with the stereo, you'd get like the schematic with it. So if it broke, you could fix it. Somehow, probably 84, 85, that just stopped happening, and we're bringing that back so that when you get a MakerBot, you can know how it works.
So I'm going to start this last question with a little disclaimer and say that, first of all, amen, brother. I'm a huge believer in the open source mentality personally, and I think we do need to rekindle a culture of making things openly, both in America and in the Western world, on the whole. And I'm a big fan of MakerBot, for that reason and other reasons. But I have 2 kind of tough questions for you that I'd just love to hear your thoughts on. Tough question number 1. When I think back to the early days of radio, when radios first started getting popular, it was because of, basically the same kind of thing where radio operators from World War I came home and they had this technology and they started tinkering with it at home. And then they would make these kits. And so the earliest radios that people bought were kits that they bought, just like these MakerBots. And that's what popularized radio. But then, the commercial reality kicks in. Big companies see that there's profit to be made, and suddenly the kits pretty much die out. And so what makes you think that MakerBot Industries is here to stay and that people will want to keep building their own open source hardware in the future rather than just buying the latest Hewlett-Packard combo model that ships free with your PC in 2020?
It's interesting. My grandpa built his own radios, and my dad is a ham radio operator, and I'm a ham radio operator.
Oh, it's interesting.
My call sign is K7GRE. And so, the radio stuff is if you're into radio, radio was the coolest technology from the 20s to probably early 60s. It was if you were a geek, you were into radio back then. And if you're a geek, you're into MakerBots right now. And I think you hit on something that we discovered as well. This idea of kits only scales so far, and we basically found with as we were making MakerBot kits with the cupcake and the Thing-O-Matic, our first two things, our first two products. We realized that there were a lot of people who wanted one and wanted to use one, but didn't want to put it together. And so that's why we came out with the replicator and why it's assembled. And what we're finding is that like really ordinary people, regular moms and dads, teachers, as well as the hardcore engineers and designers and people who need to prototype are getting them. And for the most part, most people get it and they think, okay, I'm going to do really practical things like with this. I'm going to be the superhero around the home and make stuff. And, they do make shower curtain rings and bathtub plugs and fix things around the house. But then most of what people do is they just come up with cool stuff, or they go, or they download cool models and print them out just because it's the only way you can get, some of these things.
Just because it's fun. Well, and so that leads perfectly into my next question. The tough question number 2 is that ultimately MakerBot is helping people make plastic widgets at home, right? And so the question becomes this kind of bigger one about, do we really need a whole bunch more plastic widgets at home?
So there's really two components to that. There are two-part answer to that. And one is that, plastic, it's interesting, like ABS is one of the plastics we use, and it's the same thing Lego is made out of. And I have to say, from a material science point of view, it is just such a wonderful thing. It is when you heat it up, it gets so wonderfully gooey, and the flow characteristics are amazing. But it is plastic, and it's a petroleum product. So we actually have another type of plastic we like to use called PLA, which stands for polylactic acid. And PLA is made from corn, and it'll biodegrade under under the right heat and acidic conditions. So it's something where if you don't like buying plastic stuff, you definitely make stuff on your MakerBot with PLA, and you can and you'll feel better at night.
Well, great, Josh. I believe it's time for you to summon your robotic back hair to make us move into the next class.
I summon you. Take us forthwith, hastily. And welcome back. Today we're chatting with Bre Pettis, maker, replicator, and so much more. He is the co-founder and CEO of MakerBot Industries.
We wanted to bring Bre on the show because he and his team at MakerBot HQ have brought personal manufacturing into the limelight and adding a whole new level to the DIY experience, and at the same time inspiring children and weekend hackers to master these highly technical manufacturing tools.
Very cool. Bre, you started out teaching, as you say, medium-sized people and probably inspiring them to make things of their parents' belongings. What started you down this path of creating the plastic extruding powerhouse that is MakerBot?
I've always been a tinkerer. I grew up tinkering with bikes, and then being, the person in the house who, when things are broken, I was always the person who would fix it. And I grew up with computers, so I was always just totally geeking out about technology. So, when I was teaching kids, and because of the way education has been going in the last 15 years, so much of what happens in schools is about teaching to the tests. And I got to be the teacher who taught kids how to make things. Because art is really, I got to be an art teacher, and art is kind of the last stand of, being able to use your hands in school. So, I'd always wanted a 3D printer, and it was one of those things, like, they've been around for a long time. Your sponsor of this podcast, Stratasys, really pioneered this, and we wanted one of those machines, but we couldn't afford it because they're really those are aimed and targeted at like the high-end professional market. And so we just started hacking. We're hackers, and we set up a hackerspace in New York called NYC Resistor, which was kind of like a clubhouse for geeks with lots of tools. And when we started MakerBot, we just started prototyping because we had a laser cutter, and we just started iterating. And when you have those kind of tools, you can just make things, and if they don't work, you can make it again. And if you're comfortable with failing over and over and over and over and over again, eventually you're going to get to somewhere.
Yeah.
So we just kept on trying this out and trying to make it work, and it eventually at one point it worked for like 5 minutes, and then of course the electronics let out the magic smoke, and we had to start over again. But it's one of those things.
Right, but you guys are ecstatic because it worked for 5 minutes.
Yeah. Oh yeah. We were like, we were, it made like 1/10 of a shot glass, and we were drinking like alcohol, like 4 drops of alcohol out of that thing, like for hours. So,
All right. Now you've said that 3D printers, MakerBots, or whatever will be totally common to see on desktops by 2020. What convinces you that people would buy 3D printers for their own homes as opposed to going to fab shops where higher end equipment can be shared among groups of people?
I don't think it's necessarily an either or situation. I love it when hacker spaces and maker spaces and design shops where there's lots of people get a MakerBot. Just because, and I like it when classrooms get MakerBots too, because it just means that more people are going to be exposed to it. And when you see it, like if you haven't seen a MakerBot in action, it's magic. You have an idea, you either design it or you download it. We have a site called thingiverse.com where people share things. And then you get to send it to the MakerBot, and where there was nothing, then there is the thing that which you desire. And it's sort of like being a magician or conjuring something. It's magic.
That's beautiful. Now, you mentioned Thingiverse. It's the massive maker-centric tentacle exploding from the bosom of the MakerBot community. Obviously, sharing creations is very important.
Our listeners obviously know that this was a script that Josh wrote.
What's the exciting thing about this, and how have you seen the community change and grow over the years?
I think we're going to have to add that as a tagline, the massive maker-centric tentacle. You guys are great. Thingiverse is awesome. We actually came up with Thingiverse before we came up with MakerBot because we needed a place to share our digital designs. We were like, literally, we lost some hard drives, and we were like, crap, we can't make those things again. And we've been telling people, like, someday you're going to be able to download things, just like you download books and movies and MP3s and stuff. And our friends were like, oh, that sounds cool. Where do we do that? We were like, hold on. We'll be right back. And so we hooked up Thingiverse. And it's just every day I go there and people share their digital designs for anybody to download and make. And there's just so many cool things. It's like, you can do a search for tentacle on there and you'll find stuff. There's all sorts of amazing projects that are developing there. Right now the community is working on a grandfather clock project so that you can make a grandfather clock on your MakerBot so that everybody with a MakerBot can know what time it is. It's just astounding, the amount of creativity on there. And I would actually invite all your users to go to Thingiverse, and if you have a cool project or a cool design that you've made, share it on Thingiverse. Lots of blogs go there to check it out, and if it's cool, it'll get a lot of buzz. And I'll personally want to make it if it's cool.
That's such a cool thing.
Yeah, go share all those designers, all those engineers that are listening. Don't let those designs starve on your hard drive. Set them free into the world.
Get them out there.
Let them go. Let people do cool stuff. Share. You're going to be so happy when you do.
All right, as long as it's made of ABS or lacto whatever plastic, right? So that's the next question. What you can currently print in, you've mentioned a couple of materials. What other kinds of materials have you thought about printing, and what do you think you might actually try to implement in the future?
We've got another material that we sell called PVA, which is polyvinyl alcohol, which is a material that smells like wood glue and dissolves in water that you can use as support material, and that's still experimental. We've also got an experimental tool head called the Frostruder for frosting extruder. And this is it's a syringe, and it's you need an air compressor.
Fantastic.
And you fill the syringe with whatever you want, epoxy or silicone or frosting or peanut butter or Nutella, and then you make your thing out of whatever you've got in the thing. And you do have to be a little bit careful though, and it's marked experimental. We had in 2010, we still have a laptop that hasn't recovered from the great jelly explosion of 2010.
Oh, delicious. So what are some of the things that you've seen printed that have shocked and inspired you?
I get really inspired by the types of like mechanical things. So the clock project that I mentioned is super inspiring to me. The robots, the kind of like, there's a couple like 6-legged robots that crawl around like insects that I get really excited about. And then probably the one that shocked me most was when somebody uploaded the lower arm of an AR-15. Now, this is the one part on a machine gun that is, is regulated. Like you can buy all the other parts like mail order, but this is the one part that you usually have to like register with the government. And it's not illegal to make it yourself, so it's legal, but it's one of those things that was like, whoa, you could drop, MakerBots, someplace and start, start a revolution.
Yeah. It's really interesting. There's a whole interesting, I don't know. When that news hit the blogosphere, I was definitely scratching my head a little bit. Definitely makes you think. So back on the topic of MakerBot though specifically, what are some of the advantages that you would say MakerBot has over printers from other manufacturers like the Cube, the BFB, or the Buildatron, or any of the commercial competitors out there?
We're awesome. That's our goal. That's our business plan.
I'm with you.
We just aim. We really strive to be excellent, and we're always pushing the envelope. We were the ones to come out with the first automated build platform, which is a platform so that you can make things and then it'll spit it out of the machine and make more. We're the first one in the DIY scene to really nail 2-color and 2-material 3D printing with the replicator. We just keep on. We're obsessed. We're with making this excellent for people and having them have a good experience. And we've got also a great support team. So if you have a problem or if you try something out and it doesn't work, we've got folks like literally standing by wanting to do it who will do whatever they can to make sure you get back on track.
Cool. Now, I've noticed 3D printers being used a lot more in production. Do you know of companies using MakerBot printers for production, and how are they using them?
It's one of those things where if you're going to do more than 1,000 of something, you probably want to look into having something injection molded. But there's a couple things that people have done. There's a huge business of people using MakerBots to make rep wraps, which is another type of 3D printer that's 3D printable. And so literally there's like, if you go on eBay, you can buy the parts made for a 3D printer made on a MakerBot. And there's lots of people who've actually made all the money back from they spent on MakerBot by just making parts for other 3D printers for people, which is super cool. And then there's a guy named Ed Tekian who did a project where he made action figures, and he made them so that he could configure them. So he made a bunch of different types of bodies and a bunch of different types of arms and a bunch of different types of heads. And then he sort of mixed and matched them and had a really awesome art show. And from the pictures, it looks like there were at least hundreds of these little, he had made his whole robot army. It's super cool.
Now,
Cool.
Kids that are, just being born or that are toddlers today, these things are going to be as commonplace to them as the Macintosh was to us growing up, And so how have kids in schools been using MakerBot printers, and how do you think that will influence them as they grow up?
Oh, you're hitting on something that's just really close to my heart. I just had a daughter last summer.
Congratulations.
And she's going to grow up with 3D printers just being like absolutely normal and banal. And, I can just hear her now saying things like, "Dad, do I have to, MakerBot it?"
There's one in her crib as we speak.
And, but, I think back of and I'm sure every engineer can imagine this, imagine you're 11 years old and, you're obsessed with Legos, and maybe you have like a 200-in-1, electronics project kit thing. And imagine you're 11 years old now and you have a MakerBot, and you can make anything from, your own toys to your science projects to just all the kind of most anything your imagination can make up. I just think I could have lost years to a MakerBot if I was 11 years old, and I would have learned about iteration and innovation a lot earlier. I mean, I think kids these days have a lot of challenges because Because, like, if they fail once, sometimes they don't want to do it anymore. But with a MakerBot, the cost, the material is just like so absurdly cheap that you can just make it. And if you don't like it, no big deal. You can just make it again. Or if you make something and somebody wants one, you can just say, yeah, keep it. I'll make more.
Cool. Now it's happening already, but we're probably eventually going to make sentient robots that can make themselves. Do you actually think that this is possible? And if so, will they be able to cook baby robots and also pizza in their robot bellies?
What?
I made a robot once that made cheese sandwiches. It did, and you know what? It did not save me any time. So, but it was really fun to watch.
Oh,
so
wow.
I think I love that. I love a future of more robots. Bring on the robots.
Bre, having you on the show has been even better than that time Josh mixed a bucket of mashed yams with spittle, squirting out his nostrils to form a tower of pasty orange unicorns. Thanks for being on the show with us.
Guys, it's a pleasure being on. I love your show. Keep up the good work.
If you would like to send yam buckets and tissues to EVDHQ, please address them to Josh.
And if you'd like to see tight yet inspirational unicorn t-shirts on EVD, please address those to Josh as well. Engineer versus Designer appreciates your comments. If you listen to the show and wish somebody would spray us with molten love punches, head over to engineerversusdesigner.com and spray away.
And if you want to see us spend hours shedding sheets of tweets and wisdom on the internets like dry skin, be sure to like us, +1 us, tweet us, or whatever else, as social media has been correlated with dehydration and epidermal degradation.
The show was edited by Simon Martin. Our theme music is by Ross Hartman.
We'll see you next week, and remember, without engineers, designers would be squeezing toothpaste into shapes on their face.
And without designers, engineers would be squeezing their face into misshapen representations of quadratic equations.
Punch monkey.
Monkey punch.